Okay, this section that we're going to move to now is the review of the skills for all of Chapter 6. Okay, and what I've done is I've tried to get them in the semblance of order, but also follow through with the way it was presented in Chapter 6. Okay, so the first thing that we've got to look at is just some exponent vocabulary. All right, now, what is a base number? Over here, what's the base number? It's the B, it's the big number. What's the E?
Exponent.
Exponent indicates how many times the base number is multiplied. We just got done looking at how important that was when we looked at the last section. And then the name of a B with an E is called power. That's for vocabulary, especially with Forrester. For vocabulary purposes, that's important because he talks about a power. He's talking about some exponent. Okay? Now, order of operations. Most of you know this. The order of operations is exponent first, multiplying second. This is actually -1 times 2 to the 4th, which is -16. But this is 4 -2's, which would be +16. I know, it's very tricky, but you've got to remember that. So if that's something that you forget, you need to star this and remind yourself. Okay, now I've given this handout in other ways before, but this is a summary of the exponent properties that you are supposed to be responsible for. All right, the product of two powers, there's that vocabulary word. All right, when you have two numbers, you're adding the exponents. All right, we all know that. Okay, the quotient, we are going to subtract the exponents. All right, a power of a power, whoa, a power of a power will multiply the exponents. Okay, and a quotient of a power, and that means this n is distributed to both sides of the fraction. And so this is n times a over n times b, and we might have to subtract those if the question calls for it. And then the last one is a negative exponent. Because this is the same as 0 minus a, x to the -a power is the same as 1 over a. And you're supposed to already know that and be able to use that. Now, here's what I said over here. This is important. A negative exponent is a location, not a sign. A negative in an exponent is a location. It's not a sign. So when we had this right here, this negative is a sign. Right? This negative is a sign. But if it were in the exponent, here, it's a location. It means instead of being in the top of the fraction, go to the bottom of the fraction. Okay? Now, another set of vocabulary. Index, radicand, and radical sign. What's an index? Important. What's an index? Index is the root that you're dividing it into. It's the denominator of a fractional exponent. What's it called? Index. The radicand is the number underneath.
Right.
Okay? And the radical sign is the square root sign. All right. If there is a value here, it becomes the exponent of the radicand. The number in the bottom is the root. Okay? So, I've got that in red on yours. All right? The numerator is the power of the radicand, and the denominator is the index root. Okay, now, scientific notation. I did this, it's kind of weird, because this is something you should know. Or look up here. Okay, this 17 is a positive, so it's getting bigger. The 2 is getting bigger by how many places? 17. I jump 2 numbers, 1 and 3, and then add 15 zeros.
Yep.
It's that fast. Okay? This right here is a -6. Therefore, it's getting smaller by 6 places. If I jump the 4, how many zeros do I need in front? 5 for a total of 6 places. So I have 0.0, then I have 5 zeros followed by 4, 5, 6, and you're done. The key is that as we moved up a level, this is not a whole number any longer, and so you have to count the number of digits that you're jumping in the mantissa before you figure out how many zeros you have to add. Make sense? Okay, now the second part of that is right here. Ooh. All right, you must correct 23 times 10 to the 8th power to scientific notation because that number is too large. Okay, if I take this and move it decimal point here, I've made it a power of 10 lower, right? If I don't make that a power of 10 bigger, then I've changed it. But if I lower one by a power of 10 and up the other one by a power of 10, then the changes cancel out and there's no change, right? So if this number is too big, you lower this and raise that by 1. All right? If this number is too small, we're going to do what? Raise this and then lower that.
Yep.
Okay? Not hard, but just different. Now again, and all of this comes in because as we get into Algebra 2 and higher, is that these mantissa are not going to be whole numbers. And so we've got to know how to deal with them. Now, that used to be in 8th grade. But if you didn't have it taught specifically when you're in 8th grade, that's new material. Right? And then again, until you're taught something, you don't know it. Right? After you're taught it, then you have to remember it. Okay? Now, next part. This is cool. Exponential graphs. Alright, now, unfortunately, I wish I had some colored markers to give you. But I need you to look at, there's two things. This one right here is y equals 2x. So I want you to take an arrow and point it to this graph that goes through here. That's y equals 2x. In fact, let me see if I can do that. So y equals 2x, when x is negative, it's hugging the axis. It comes through 0, 1, and then shoots up into positive infinity. Okay? Now, when the base number is less than 1, or when the exponent is a negative, it throws the 2 to the bottom of the fraction. What it does, it reflects across the y-axis. So you should know that the parent graph looks like this, and that the inverse looks like that. So those things come across. All right, now, later on, we're going to get to a question that talked about the logarithm. So the difference between this and this are reflected across the y-axis. But the logarithm of base 2, which is the inverse of this is base 2 to the x power, this is the logarithm of base 2 to the x, they are reflected across the line x equals y. But the key there is, instead of being here, it's over here at 1. See the difference? It's not down here. It's phased out. How many degrees is it phased out? Isn't it 90 degrees? Right? So this is just rotated 90 degrees. Right? And then you're going to come through here. As the log gets bigger, this goes to positive infinity, but it's going to go at a slower rate than the exponent. Okay? So here's another one. And I just found this. This is, the blue dot is y equals 2x. All right, the red one, y equals 3x, goes up faster and gets down to 0 or close to 0 faster because it's 1 over 3 instead of 1 over 2. All right, and then the reverse, 0.5 is the same as the blue 2, right, because 0.5 is 1/2, and that just shows again the reflection across the y-axis. And again, this is all part of the things you're supposed to just know from chapter. All right? Now, I just said all that right there, so I'm not going to repeat it. All right, exponential equations. All right, this is the middle section of chapter 6. Okay. You have growth if b is greater than 1. You have decay if b is between 1 and 0. If the x is a negative, it's not talking about growth or decay, it's flipping the sign, so you still have to know what the b is, but it's just going to flip. Alright, so this is, look, this is what? That's the b. So is it growth or decay? It's growth. Why? Because it's greater than 1. Okay, what about this? It's decay because it's less than 1. So this is getting bigger by 60% every time that we multiply. This is getting smaller by 6% every time we multiply. Okay? Now that gets us to the functions themselves. Alright? This I just went over. If you have f of x and you increase it by some value, it's the same as the original and b to whatever that value is. So if I increased it by 3, then this would be b cubed. If I increased it by 2, then this would be b squared. Okay? And that's the example that we had from the book. Alright, now logarithms, fun stuff. Okay, first of all, log of x equals e. The e is the exponent. This is only true, log base 10 of x equals e, only if 10 to the e power equals x. Okay, so that's your examples. Now, I thought that this was helpful. If you're converting between logs and powers, there's 3 different things. One is that the x is here. This is the missing value. This says log base 2 of x equals 3. Alright, so that means 2 to the 3rd power equals x, and that's easy to solve. Okay, this says log base 4 of 16 equals x, so that means that 4 to the x power equals 16. Right? If 4 to the x power equals 16, if you know the fact, x equals 2, because 4 times 4 is 16. If not, then because you have 2 powers, you do log of 16 divided by log of 4, because of this here. Okay, and that's rule 5 from down below. Now this says log base x of 64 equals 3. That means x to the 3rd power equals 64, so I take the cube root of both sides. So these are the 3 different ways that they could represent the variable, and you have to be able to transform it back into something that's useful. Okay, so if you think about that, that will help you understand. Now, next part is the, whoa, what happened there? No. Go away. Why is it cleaning? Push exit. Okay. All right. These are the logarithm rules from the textbook. All right. If you are multiplying, you add the exponents. If you're dividing, you subtract. If you have power of a power, this number comes out here. If you change between 2 different bases, the log base b of n means log of n divided by log of b. Okay, and then finally the identity one, in which this is important. Log base b of b is 1. So log base b of b to the x will be 1 times x. Okay, inverse functions. Now, this is how I teach inverse functions. You write the function and then exchange the x and y variables. Then use algebra to get y equals, and that is the inverse. Okay, so here's the example. All right, you're given this. All right, f of x equals this, and you know that f of x is the same as y. So step A says we're going to change the x and y. then I've got to get y equals, so the first thing I'm going to do is subtract the 4, then I'm going to divide by the 5, and then I'm going to take the square root to get the y by itself, and that makes the inverse of this function to be the square root of 1/5 or 0.2x minus 0.8. It just is what it is. But the key to it, I believe, is exchanging the x and y first so that you know what you're trying to get to. Okay? And questions? Went through it pretty quickly, but that's a good, now, if I were you, I would take that handout, I would punch holes in it and put it in your notebook, because that's a good summary. So when you're working on the tests and the quizzes that you're going to be having in the coming week, you'll be able to refer back to that as maybe a quick way to remind yourself of what those skills are. Okay, all right, thank you for your attention, and now we're getting ready for the new material.